Picture a 58-story luxury high-rise packed with multi-million-dollar condos just towering over downtown San Francisco. It's an absolute marvel of modern engineering, finished in 2009. But there's a massive hidden problem. This multi-million-dollar behemoth is literally sinking into the earth. So put on your forensic investigator hats. In this explainer, we're going to dig into the dirt and uncover exactly how one of the most expensive residential buildings in the West turned into an absolute engineering nightmare.
And we're not just talking about a couple of cracked tiles here. The stakes are terrifying. The Millennium Tower has sunk over 18 inches into the ground. But here's the real kicker. It's not sinking evenly. It is currently leaning a staggering 29 inches to the northwest. That is a massive out-of-plumb tilt for a super heavy concrete structure, especially when you remember it's sitting right in one of the most active earthquake zones on the planet.
So let's look at the anatomy of a sinking foundation. To really grasp how this disaster happened, we need to examine the body of our structural failure. When engineers build skyscrapers, they generally have two main choices for deep foundations. Option A, deep piles. These go all the way down until they literally hit solid bedrock. It's like resting a heavy pillar directly on a hard, concrete floor. Option B is friction piles. These rely on gripping the surrounding soil. Imagine taking a really thick nail and driving it into a block of dense foam. It's actually the friction along the sides of that nail holding the weight, not the tip resting on anything solid.
Now, the original engineers made a really fascinating choice here. The Millennium Tower was built on a massive 10-foot-thick concrete mat, supported by 942 of these precast friction piles. They drove those piles 80 feet deep into a layer of dense sandy soil called the Colma Formation. But right here is our critical piece of forensic evidence. They stopped drastically short of the rock-solid Franciscan complex bedrock. That solid bedrock, it was sitting 250 feet below the surface. They didn't even come close.
And that brings us to the prime suspect in our mystery, a layer known as Old Bay clay. Because right beneath those 80-foot piles sits a massive, incredibly thick layer of ice-age marine mud. Think of this clay kind of like a super dense memory foam mattress. If you take a heavy bowling ball or, a 58-story skyscraper and place it on top, the foam doesn't squish all at once. It compresses very, very slowly over time.
Which brings us to the dewatering trigger effect.
See, the original geotechnical engineers actually knew about this clay. They predicted the building would settle, maybe 4 to 6 inches over its entire lifespan. So why did it sink 18 inches instead? Well, let's look at the timeline. Construction wrapped up in 2009, but between 2010 and 2014, early signs of accelerated settlement started to pop up. They kept it pretty quiet, though. It wasn't until 2016 that the devastating 29-inch lean became public knowledge, and man, that sparked a massive flurry of lawsuits and straight-up panic.
The real trigger here? Dewatering. The Millennium Tower doesn't exist in a vacuum, right? Massive adjacent projects, like the Salesforce Transit Center, required huge, deep excavations. And to keep those giant holes dry, contractors had to constantly pump groundwater out of the earth. Let's go back to our Old Bay clay. Imagine it's a wet sponge. When you literally suck the water out of a wet sponge, what happens? It shrinks, it compresses. They essentially squeezed the soil sponge right out from underneath the Millennium Tower. The data here just punches you right in the face. Look at this. The original estimate was a super manageable 6 inches of total settlement, but by 2020, they measured 16 inches. Fast forward to 2023, and it was over 18 inches and still sinking differentially. That means the northwest corner was dropping way faster than the rest of the footprint, which is exactly what caused that severe, terrifying tilt.
So the obvious question, is the skyscraper actually safe?
That was the high-stakes question every single person in San Francisco was asking. Is this leaning tower literally going to collapse? To answer that, the city commissioned an independent structural safety review back in 2017. They ran what's called nonlinear response history computer analyses. Basically, these are extreme earthquake simulations. They needed to see if the building's concrete core shear wall and its moment frames could handle the shear stress of that massive lean, especially if you combined it with a major seismic event.
And surprisingly enough, the data offered a massive sigh of relief. As Dr. Gregory Dyerland concluded, the settlements experienced by the tower have not compromised the building's ability to resist strong earthquakes. Because the building actually has a really robust dual structural system, the computer models proved it could safely withstand a maximum considered earthquake. We're talking an event roughly equivalent to the catastrophic 1906 quake. So yeah, it might be leaning like crazy, but it wasn't going to fall over.
Now, let's talk about the bumper jack fix.
Okay, so it was earthquake safe, but obviously you still can't have a massive skyscraper slowly sinking into the mud forever. We enter the resuscitation phase. The engineers decided they finally needed to do what frankly wasn't done back in 2005. The plan? Step 1. Drill brand new concrete piles 250 feet down, anchoring directly into that solid Franciscan complex bedrock. Step 2. Build a massive new concrete collar. And Step 3. Use incredibly powerful hydraulic jacks to physically shift the weight of the building onto those new rock-solid piles.
The original fix actually called for 52 of these massive new piles, but in 2021, an absolute nightmare scenario unfolded. The intense vibrations from drilling those deep holes actually disturbed the Old Bay clay even further. Think about that. The drilling itself caused the building to sink and tilt even faster. They had absolutely no choice but to hit the emergency stop button and halt the entire project.
So the engineers had to scramble and completely revise their strategy. Instead of 52 piles, they figured out they could achieve stabilization with just 18 massive concrete piles. These would be installed strategically right under the sidewalks. But crucially, they decided not to rigidly attach them to the old foundation right away.
The mechanics of this revised plan are honestly genius. The lead engineer likened it to putting a bumper jack next to a flat tire. They sleeved the new piles straight through the existing concrete slab, anchored massive steel beams above them, and then used those hydraulic jacks to literally, manually lift the colossal weight of the skyscraper off the failing clay. They transferred all that load down the new piles directly into the bedrock. And finally, in June 2023, they achieved victory. During the final load transfer, each of those 18 new piles successfully took on 1 million pounds force of the building's weight. 1 million pounds each! And the result? The foundation immediately recovered nearly an inch of tilt, and the expectation is that it's going to continue to slowly right itself over the coming years. They finally stopped the sinking.
The Millennium Tower is basically the ultimate case study in why saving money by skipping bedrock foundations never ever pays off in the long run. The soils beneath our cities do not care about your budget, and underestimating the geology below will always catch up to you. If you want more deep dives into epic engineering failures and fixes, make sure you hit subscribe for more engineering breakdowns. But this whole saga does leave us with a pretty chilling thought. If a towering achievement of modern engineering can be brought to its knees by the very ground it stands on, what other hidden disasters are ticking away beneath our feet right now? Thanks for joining this explainer.